Okay, and we're back here. We are doing now bigger degrees, bigger than 90 degrees angles in radians, finding trig ratios of all of them. So one way we could tackle this is by converting and then using our reference, right? So if you do this conversion, this becomes sine of 240 degrees, this is. Okay? And then we might draw, our reference here. So 240 would be down here. It's 60 degrees past 180, so this is really sine of 60 degrees. And then when we look at our reference, so using this table that we have in our notes, sine of 60 degrees is root 3 over 2. And notice root 3 is negative here because I'm coming down from the x-axis. So sine of 240 degrees is negative root 3 over 2. Okay. So that's one way we could tackle is by converting each time. But I want to introduce something else that we can use as a reference to tackle these that will make our lives a little bit easier in the long run. So what we have here is the unit circle. And I'm going to post this on the unit website so that you don't have to copy all of this down. Okay. So what this is if you remember learning multiplication, I made this reference before. Before you knew that like 8 times 9 was 72, what you might do, when this one goes all the way up to 20, what you might have done is looked it up in something like this, right? And eventually you find that you memorize 8 times 9 is 72, and you don't need this anymore. Although I, for example, don't know that 18 times 17 is 306 off the top of my head. But like most of you have up to 12 memorized, hopefully. This unit circle is our multiplication table, but for trig functions. And it's going to work the same way. You're going to use it as a reference. This year I don't expect you to memorize any of it. You're going to use it as a reference. You do need to know how to use it to answer these questions. Okay? So think of it as like a tool, like a calculator that you're going to use. And by the way, like your calculator will not spit out negative root 2 over 2 for you when you type these in. So you need to be able to use this to get these exact answers. So the way you use this, it's pretty straightforward. So I'm going to come around the unit circle to my angle. And remember it was 4 pi over 3. And where this comes from is actually, if we had more time this year, I would actually have you derive it yourself. Because it's not very hard. Where this comes from is just making that reference triangle for all of these common angles. And notice these are all special angles, right? So you already know enough math to figure these out on your own. This is just a reference that's going to make this a little bit easier. Okay. Notice each point in the circle rather, has an x and a y. Actually I wrote that backwards. So the way these are written is cosine is your x coordinate, sine is your y coordinate. Okay. And that works because unit circle, that means like this is a circle with radius. Radius is 1. Okay. So it's saying like negative root 3 over 2 in this example over 1. Because 1 is the hypotenuse. In any case, like how to derive this is outside of the scope of this video, but it's just based on all of the individual reference triangles. So like if I want to know sine of 30, I draw this triangle. That work is now already done for us. Okay. So what I mean by it's written as x is cosine, sine is y, is if I look up this angle sine of 4 pi over 3, if sine is y, I'm looking at the y coordinate in the unit circle. Okay? So I can use that to look up the solution to this problem without having to think about converting it and all of that. So that's what I want you to use for this lesson. We'll look at a couple more examples. So here we have sine of 5 pi over 3. So all I'm going to do is I'm going to come around until I find 5 pi over 3. being good at fractions helps you find these, because that tells you 5 pi over 3 is bigger than 3 pi over 2, so we should be looking over here. And sine is going to be the y coordinate. So sine of 5 pi over 3, the negative square root of 3 over 2. Okay. So you have a sense, based on the work you've done prior to this lesson, of where this comes from, but this lesson is really just about learning to use this reference. Let's say I wanted to do cosine of 5 pi over 3. I would do the same thing. I would come around to 5 pi over 3, and then cosine is my x-coordinate here. So cosine of 5 pi over 3 is 1 over 2. That's it. That's all there is to it. We'll tackle a couple of complications now. Okay, here, this is something we haven't seen in a minute. Secant of 3 pi over 4. So we have to remember what secant means, so you can reference your notes to figure that out. Remember, secant is a reciprocal, and secant is 1 over cosine of 3 pi over 4 in this case. Okay, so what that means, this really means flip the fraction. And we're flipping the result we get, not, we don't want it, the cosine of 4 over 3 pi or something like that. So we're leaving this alone. We're flipping what we get. So what I'm going to do is I'm going to find 3 pi over 4. That is here. Cosine is my x coordinate. So this becomes 1 over negative square root 2 over 2, which becomes 2 over negative square root of 2. So this is secant of 3 pi over 4. Okay, easy enough, but we have to rationalize. Okay, so I move the negative up, just because I don't like that negative in the bottom, and then I multiply by root 2 over root 2. This ends up being negative 2 root 2 over 2, and then those cancel, right, those 2's, and I just get negative root 2. Okay, so these reciprocal ratios, because of the way this is written, you often have to simplify them some. And last thing you need to know. So tangent of 5 pi over 6. So remember I said this is written as cosine of your angle is x, sine of your angle is y. There's no tangent anywhere involved, right? The last thing you need to know for these lessons, or these problems rather, is that tangent of an angle is equal to sine of the angle over cosine of the angle. Okay, and that's true always, but it's particularly useful here because I can use this same reference now to figure out what tangent of 5 pi over 6 is. So tangent of 5 pi over 6, well, is going to be sine of 5 pi over 6 or cosine of 5 pi over 6. This is just a fact that we could prove using a triangle if we really wanted to. And then I just looked those up in the table. So 5 pi over 6 is here. Sine is my y-coordinate, so that's 1/2 over negative root 3 over 2. And then if I'm dividing those fractions, I flip the bottom, take the reciprocal of the bottom, and multiply, right? And in this case, I have a 2 on top and bottom that's going to cancel out. And then I want to rationalize, so I'm going to take times root 3 top and bottom. That gets me root 3 over 3, and then we have a negative. So use this unit circle as a reference. The two things you're going to need besides that are this fact right here, so make sure you capture this in your notes, and then your definitions of your reciprocal functions. So that's secant, cosecant, and cotangent. Cotangent, by the way, by this same fact, cotangent is cosine over sine. So all 6 of those come up in this lesson.